In question 5 in 2022, we had a balloon pump made from a cylinder. You should write down the volume of the cylinder straight away. Pi r squared will be a circle. H will bring in the length for the volume of the cylinder. Internal diameter 6. You're going to write down r is equal to 3. You can see that there, and the height is equal to 20. As you go, read the question, write down the variables. Each time the pump is pumped, it passes one full cylinder of air into a balloon. Show that the volume of one full cylinder of air is 180 pi centimeter cubed. Pi r squared h is equal to pi, it's in terms of pi, by r squared, 3 squared by h, which is 20, and 9 20s are 180, so equals 180 pi. Part A. Part B, Dara is inflating a balloon in the shape of a sphere. When fully inflated, the balloon has a radius of 15 centimeters. Find the volume of Dara's balloon when it's fully inflated. And it says give your answer in centimeters cubed in terms of pi again. So let's do it up above here. So its volume of a sphere is 4/3 pi r cubed. And if we fill in our variables here, we're going to get 4/3 by 15 cubed by pi, and this is going to give 4,500 pi cm cubed. Then we have Dara pumping the pump. A lot of pumping pumps once every second. So how long will it take him? Well, he has to fill 4,500 pi, and each pump is 180 pi, and he does 1 a second, so it's just 450 over 18, so that will give 25 seconds. And part C, Gustav is inflating a bigger balloon in the shape of a sphere. He also pumps the pump once every second. They all pumped out. His balloon is fully inflated after 50 seconds. Find the radius of Gustav's balloon when it is fully inflated and give your answer correct 1 decimal place. Okay, so we know Gustav, we know the sphere is 4/3 pi r cubed. We don't know the radius, but what we do know, if he pumps for 50 seconds at a rate of 180 pi per second, he will have 9,000 pi centimeters cubed of air in the balloon, which is equal to 4/3 pi r cubed. So the pi's cancel, and if we multiply by 3, we get 27,000 over 4, 27 with 3 zeros over 4 is equal to r cubed. Correct the 1 decimal place, we need to get the cube root. R is equal to 18.8988, and 1 decimal place will be 18.9 centimeters for Gustav's balloon. Up here, that's a big balloon. Question 6 sets 80 students in a group. The total inside this box is 80. They were asked what they had done during their summer holidays. Some of the students got a job, some went on holidays, and some did both, and some did neither. 1/5 of the students did neither. I'll write that here as 1/5. 25% of the students got a job, that's a quarter. I'll write them maybe as 0.20. I'll take out the fifth, I'll do decimals here. A job, 0.25, 25%. Of those students who got a job, half also went on holidays. So that's half of a quarter, which is an 8. 0.125 would be an 8 if you left it like this. A quarter if you want to leave them like that. So that means that there's 0.125 in there, which means if there's 0.8 left in the two circles, the 1 minus the 0.2 is the 0.8. And we have a quarter in here, which is 0.25. So 0.8 minus 0.25 will give us what's left in here. Then we'll just check they all add up to 1. This is 0.55. So let's just check now. 0.125, 0.125, 0.2 and 0.55 do in fact add up to 1. So what are we asked here? Work out the total number of students who went on holidays. Now we could have done it in terms of numbers at the beginning, but the number who went on holidays is 0.55 plus 0.125, which is 0.675, 5/8 of 80, which is equal to 50. And if we do the two circles again with numbers, we had 80 in total. A fifth of them, which would be 16, is on the outside. A quarter of them is 20, and half went in here and here, which would leave, I'm kind of just doing this to show you that this is wrong, would leave, what would it leave, 44 in here, 20, 64, 80. So I've just said that was 5/8. This is actually 54. Just be careful with these answers, and this works out. You can see here 54 students went on holidays. I should probably put J here, H here, and U equals 80. So there's a couple of ways to approach this one. Question 7 is your classic indices. What's the rule here? Amy picked 3 values that were all the same. So this is true up here. So 4 plus 4 plus 4 is equal to 12. Joe picked 3 values that were all different. So he could take 3, 4, and 5. Any numbers that add up to 12. You can have a load of selections here. In part B, we're asked to find the value of m so the following is true. So the left hand side has to be equal to, turn your phone off when you're working, the left hand side has to be equal to b to the power 10. I'm putting a 1 in here. So if I bring that up, it's going to become a minus 1. So on top I have b to the power of m multiplied by b to the power of minus 2 multiplied by b to the power of minus 1 is equal to b to the power of 10. On your rules of indices, these 3 numbers have to add to give 10. So you see m would have to be 13, minus 3 is 10, m is equal to 13. That's 13 minus 2 minus 1 is equal to 10. Question 8 has the diagram below. 2 buildings, A and B. Diagram not to scale. Mary stands at the top of building A. Here's building A here. Mary stands at the top. Here she is. And she's 220 meters above ground, which is given in the diagram. So we're just dealing with trigonometry here, triangles and angles. What are we asked to find? So she wants to work out the distances marked y and z. Here's y and here's z. That's the distance from the top of building A to the bottom of building B, and the height of building B respectively. A lot of information, but really all we have here is 2 triangles, and we want to find y and z. So to build up to y and z, part A, find angle C. So we have a triangle here, C inside it, 154 on the bottom, 220 opposite. We could use Pythagoras to find y in a second. And we have a 90-degree angle in here as well. And we have a 35. So C is just going to be 90 minus 35, which is 55 degrees for part A. Part B, Mary works out that the horizontal distance between the 2 buildings is 154. Use the theorem of Pythagoras to mark out y, or to work out y. So Pythagoras, you know, the square root of the straight sides squared and added together. That's a 154 squared, gives me y. So y is equal to, the calculator gives 22 root 49, but we're asked for it correct to the nearest meter, as you can see here. So just change the calculator. 268.54 to the nearest meter is 269 meters. In part C, use trig to work out the value of z, the height of building B, and give your answer correct to the nearest meter. So let's see what we need for z. So z is the whole way up and down here. And we have 154 down here, which also applies to here. So I have an angle and a side that will enable me to get this part here if I need to. And if I do that, if I call this x here, you can see that the 220 plus x will give me z. So just draw your triangle again. 20, 154. We're looking for x. We're looking for opposite, and we have adjacent. The two straight sides is tan. Tan 20 equals O over A, which is x over 154. So the maths involved here, 154 tan 20 is equal to the opposite side. I'll just write OPP so it doesn't look like a 0. So 154 by the tan of 20 is 56.05. 56.05. And if we add that to 220, we will get 276 to the nearest meter for the height of building B.